welcome back to my YouTube channel. And today we'll be discussing Geohash. Before moving on, let's know why do we need Geohash? Okay, so you have seen many systems out there where you need to see people's location. For example, you must be assuming how Uber get to know that what all riders are there in your location, or how Zomato Swiggy knows to which rider to assign for a particular order, and it must be doing it based on the location of the rider, whichever is closer to restaurant. Okay, so how does it work? Or maybe you will be wondering, whenever we open a map, we want to see places nearby me. How do we get to know that? Okay, so let's see how people design these stuffs. Okay, first of all, when we talk about location, first thing in our mind comes up is latitude and longitude of a particular point. Okay, so now you say I'll just create a database like this of locations where I'll have latitude, longitude, and name of that location. Okay, and if I want to search things nearby me, or so I must be having some radius like 1 kilometers radius places which are within that get me that. Okay, so for that, what we can do is we can run this query simple. Okay, so select start from location and latitude between your latitude radius and longitude also between that. So you'll say that it will work. And why do we need geohash, and why are not we using this? So problem is, there are so many of data, so many new locations out there, and running this query every time from the database is uh, very much painful, and it will bring a bottleneck some or other day. If we are talk in terms of real world examples, there are so many locations on maps. If you open Google Maps, you will say every point has its location. There are so many things, so obviously it won't work. This is not built for it. Okay, so what else we can do? So let's get to know how Geohash will help us here. So this is the globe. Okay. So this based on this globe, we have latitude and longitude. What if we do one thing and make it assume it like a square box? We can assume it like this. Okay. It is very common. So we can do it. We can just expand a globe in 2D and we will get to see something like this. And after seeing this, what if I say we can divide this whole area in multiple parts? Let's say I divide it like this. I divide it in four parts and I name it 0, 0, 0, 1, 1, 0, and it will be 1, 1. Okay, so we can do it. Na? Again, to one area we can divide again, and we can keep it doing until we get the very small part of it. Okay, we can continuously do it like this. And if when so if based on this only, if someone asks where is India located, so you will say that it is at 0010. Correct. So yes, it is at 0010, and if we encode it to base 32, you will say like India is at 0010, which is 6. Now, if I create a table similar to this, just I'll do that. One. Okay. I want to. I'll be having a ID. Or I'll say uh, hash key name. Just that. I want these things. Okay. Or we could. So what we can do here is, as soon as I want to know places near me, and if I'm in India, I'll say get all places which are at hash key 6, and I will get that all places. I will get all the places in this square rectangle, a square or rectangle, you can say, in this area. Okay. So if I am here anywhere in this area, I have to just fetch my based on my key hash key, and we can do in indexing here on hash key, simple one hash key. On based on that, I'll get list of the places which are exist in that hash key. So let's see how small we can divide it into. Let's suppose we keep on dividing. This is the globe size, actual globe size. Okay, now if we have divided into just four parts, it is what it gives. Now, if we divide it further, uh, more length will be two, and more and more and more. And seven will say that we are less than a kilometer of radius we have. Okay, so if we somehow divide this our area in this, and based on this we calculate the exact location of every hash key of every location, and we place in a database and make it our hash key as index. So we will obviously get location of nearby places or nearby things in just O1. We don't have to run that heavy queries now. Okay, let's suppose you want to know the location of Google headquarters. So it in real world the hash key is this, and when we encode it in base 32, it gives something like this. So see, now Google's headquarters hash key is so small. Okay, so like this, all the places where you see that the location of particular user is fetched, this is only it is used. There is one more technique which is called quad tree. I will discuss that in another video. But now let's get to know the advantages and most importantly disadvantages when not to use this. Okay. So let's suppose you are finding people now. Advantage you must be clear. Like we have talked about, why are we using? So advantage are pretty much clear. Like if we want to know places near me, we'll get easily whatever persons are near me. Okay, by this. Like Uber, I'm assuming it must be using this only. Um, well, and it might use the advanced version of geohashing, like instead of divided in squares, it must be using some hexagonal structure because if you are at this center point, this point is closer, but this is far. Diagonals are far. In hexagonal, in most circle-like circles, when you go, you will see that all the points from center are nearly equal. So I'm assuming they must be using that only. So yeah, so advantages are these. Like if I want to find people or riders or delivery agents near me, in that cases it is very helpful. But when I search like what about fetch me places near like restaurants near me. Okay, so when I'm searching restaurants near me, maybe there are no restaurants in my hash geohash. So I want to know then restaurants near being different geohashes also. In that case, this geohash won't work, or maybe there are 1,000 restaurant, and ideal situation is geohash granularity should be till 10 places. So this is not the correct way for that kind of problems to solve. Like we should not we cannot use geohash because there's times when we get nothing in our hash. There are times where we get more than required. So that is good in case of Uber where we are searching for riders or drivers. That is good in that case because they are only specific to that area, that circle. Okay, but not in other cases. So in that cases, this will not work. Most probably, if I want to, if there is no restaurants in this area, so what I'll do is like this. If it is something this geohash, I will say that it must have become like this based on binary. And what if I see that the prefix? So the nearby areas prefix will be mostly same. So I can search based on that also. Like I'll do like operation on something like this modulo. Okay, but it won't work in every cases. For example, uh, this place, the granular of this place and granularity of this place may have uh, starting same because they started from uh, same binary. So in this case, it won't work. You will get this result most of the time correct by doing modulo of prefix, but not every time. Okay, so there are edge cases like one, for example, if this is the area and its prefix can come here also, or so this is wrong now because this is too far from here, and also it is in different geohash, and the prefix of this geo, or maybe I am at this position. If I do prefix match, I will never get area near of this because the prefix of this one, left side and right side will be completely different. So I will never get this. So this is one disadvantage of using geohashes. So it depends on what where you want to use, in which scenario you want to use. Okay, so I think we have covered what geohash and how it is used. Let I'll create a video on quad tree also, how we are solving this problem of searching nearby places. So quad tree will help us to know that. Till then, please let me know if you want to see a video on any other topic.